Hey, what's up YouTube? Back again for some more coursework on BACnet. We're on day 3 of our AI generated coursework in the Python BACnet Stacks playground. So this is just a repository I created recently. It's actually including like a Python mini challenge to learn a little bit of Python, some simple algorithms, and like a final little project where we'll make like a little CSV file logging app on a Raspberry Pi or something. So yeah, let's get started. So we're into some Python basics. On the first couple videos we covered using a BACnet scanning tool, where I'm just using this one right here, where you can just drop it down, you select your IP address. This is what I wanted to talk about today. So right now I'm discovering a couple fake BACnet devices on my test bench. So these are actually Python scripts running on a Raspberry Pi that emulate how points would look like in a real live building automation system. But ideally you would do this on a live HVAC system, but some of us don't, probably many of us don't have a live building automation system to play with. You can always play with a fake one if you have some spare Raspberry Pis that aren't doing anything. Like I was saying before, this also ideally you would want to take some introductory Python programming language, where we'll cover like the basics here. Excuse me. Just looking at the fundamentals of Python, some loops and control structures, data structures, and also algorithms. This is like semester of 1 computer science school, and then you branch into like more of like data science or advanced algorithms and cryptography, machine learning, so this is like way before that. And then to just play around with Python and BACnet, you don't really need to get into that. But I highly recommend it. I highly recommend this course. I learned a ton, and it's one of those things where the AI is available, but you try not to cheat with AI to actually learn something. So I think I'm going to be kind of preaching this a lot in this course. Okay, so let's get started. Day number 3, working with strings. The goal: understand how to create, manipulate, and spec strings in Python. By the end of this lesson, you'll know how to build strings using quotes, concatenate, and then repeat, and access individual characters, slice substrings, and measure the string length. A string in Python, I think people actually could consider this like a data structure. So like we were talking about before, you can hold data in a list or an array, or a dictionary. Like this is actually like a data structure in MQTT. I think you publish string looking data to a topic. So it doesn't just have to be like a sentence in a book. You can look at it as a data structure. A string is a sequence of Unicode characters enclosed in single quotes or double quotes. Python lets you embed quotes inside strings using different quote types, or escaping backslashes. For multi-line text, you use triple quotes, span several lines. Some coding languages only let you do one or the other, but Python lets you do both. Strings support indexing and slicing. Index 0 refers to the first character, and negative index count from the end. And slice syntax is like that: start and stop with a colon in the middle. Returns a substring from start up, but not including stop. Okay. The built-in function length, len, returns the number of characters in the string. So here we go. This looks pretty basic. Let's get back where we were yesterday. So yesterday we're covering a little bit of math syntax. If we just delete, whoops. We also covered installing VS Code and also Windows Terminal. So we run this by using terminal here in Python. If you can, you might as well just get used to trying to run this. This is the proper way to run Python programs, I think. You can also do it through a built-in tool that comes with Python, but I wouldn't recommend doing that. I would just jump right into running Python scripts through the command prompt. I think you can also run it in Python in the browser or IPython if you prefer that, but I kind of like doing this stuff because it's more like real software engineering. Data scientists might use Python in the browser, but I actually kind of like running Python more of like from a software engineer standpoint. So we could, let's see what this does. So this is our little tutorial here. Okay, so we could go, let's add some print lines here. So we could print, I think these will just print characters. So I'm just gonna add some print statements up here. Whoops, actually I have to do it below. Gonna get some of these commas cleaned up. These lessons are all created by ChatGPT agent mode, which I think it did an okay job. I actually recycled the course content from another one I'm creating for brick modeling. So I noticed that it actually included a bunch of stuff from that in here too, which was not what I anticipated. But I think it's okay. All right, so then let's see what this all comes up with. So here we go. So this is kind of separate. Okay, so this is just a greeting, hello world, a quote here, and then I think with these forward slashes, it might put it on a new line, or you might be able to go like this. This comes from the C world, I think. If you program in C, I think it's kind of similar. Multi-line, if you see how that string has 3 dots, or 3 the quotes, that's for like multi-line. So we could actually, probably not even worth running that because I think it's pretty self-explanatory, but we could actually demonstrate. So like when we installed VS Code and we had our extension set up for Python that makes things easier, you can actually just highlight whole block of code, and then you can just do 1, 2, 3, and then that'll automatically put these larger blocks of codes to comment out with the three quotes. So, and then this will just print that. So HVAC, a string plus a string, plus 10 of those. So this looks interesting. Python script lesson, and then hit when I'm doing this too, like when you type in the command prompt, you can just hit type in part of the name of the script lesson, and then hit tab. And like on Linux, and then in PowerShell, like we're running with the Windows Terminal tool, you could just tab complete everything. It makes it a little easier. Hit enter, and it looks like it just printed 10 of these characters. So what it's doing, it's actually this little hyphen character, and it's just multiplying 10 of them. So we could even do full, if we even wanted to put this in between. I think yesterday we talked about F strings as well. So we could even do, let's do something fancy, times 10. I think we could do 10 times 10 up here. And then we could even do, keep the print statement. And we could even do make full down here. Here, let's try this. Let's try a new variable called full plus separator equals full plus separator, which should print both of those together. So, and it didn't. Oh, that's because I wasn't printing the right variable. Ta-da! So we got 2 of the strings printed. And like, I think like what you have to be careful of is like you can't print a string and a number at the same time. Like that'll error out because you can't combine a string and an integer. An integer is a whole number. But this is just multiplying a hyphen times 10, so you get 10 hyphens, which is still a string plus a string. This will all make sense here in a couple minutes because we actually use this to do BACnet requests. So if we do this, then we get, so this first word is BACnet right here. So the first character in the word is being indexed by the index 0. So that's index 1. So BACnet has 6 characters in it. So the 5th index should be T. If we run this again, see how the first index 5 is T in BACnet. So that's index 5 because everything is always indexed at 0. And this is like, looks like a shortcut. Index -1 is the last character. And then a substring within would be these guys right here, I think. So it would be like the letters A through E, or ACN. And then the length of a word. I use this quite a bit. This is something that you'd use in algorithms quite a bit, is this length. It's a built-in function with Python that's built into the coding language, and it returns that BACnet was 6 characters long. Pretty easy. So let's mini examples. Okay, let's just get back to VS Code. Maybe do actual like something fun. So this is just some more stuff, same examples. And then if you want to declare like a path on your computer to a program, like BACpipes, legacy BACpipes required a configuration file in the INI format. So you would do like this R, I can't remember what that stands for, but this is how you would define a path on your computer, and if you wanted to read in like a config file. Okay, so let's do something more fun. This is how we will program in Python a little bit more. So if you remember on the test bench, I have a fake VAV box running here. So these are just fake points. I showed this on the first video of just, we'll get into this later, but there's a Python script that's actually defining these variables. And then there's like little fake random numbers it's just coming up with. This kind of mimics how a real device could look in the real world. So just remember, okay, so let's try it. Remember this. This is a hardware address. Or not hardware address. This the hardware address for this one, because it's BACnet IP, would be IP address 192.168.204.12. So maybe I'll write that down. So I'll even put our comments here. 192.168.204.12, and then we want to try. So this is the instance IDs right here. This is when you do a BACnet discovery, how we did a BACnet discovery with this tool. Sorry. Every time you want to refresh it, you have to close it and reopen it again. So when you do a discovery in BACnet, that's like with the virtual addresses. And then the Python script for the fake VAV box, it's hard coded for a virtual instance or virtual address or device instance. ID is 3456789, I think. So this will go when we hit the search. Shoot, I forgot to select my IP address to the proper IP address for my local area network. So I have to close and reopen it. So this is my local area network for this Windows PC I'm doing this tutorial on. So I selected the right NIC card for my host computer, and then this tool is going to send out a BACnet whois to my test bench, to my 3 Raspberry Pis running fake points, and then if everything is working properly, these BACnet devices is on the test bench, in which you would see in the real world, they would return an IM. So these devices are returning. This tool did a BACnet whois, and then which we'll do in Python too, and then it's the devices running the Python code returned an IM device blah 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 34567890, and my name is Ben's fake VAV, and this is my hardware address. And I think the colon BAC0 means that it's running like this is like a UDP. This is like I should look this up. We could even ask ChatGPT. Maybe I'll make that a mental note for tomorrow. But what the colon BAC0 means, that's something unique to BACnet. So we just want to look at device 3456789 and analog input 1 for zone temp. So let's try making a script in BAC0 for analog input 1, and then we'll try and read the same value. So this would be a sensor value, present value. There's actually a whole different properties that we'll get into at some point in time, but for the most part, everyone always deals with, including IoT, like the data, present value, the sensor readings, but there's more properties that you can read from this point. Okay, so we just want analog input 1. So this is actually 90. Okay, so I'm just going to look at some notes from some older code here. So we could just do, I haven't played with BAC0 in a little while, but I should have it up to date. So that's the BAC0 package, and then we want to use async IO. So this is another library in Python. It might be built into Python. I don't think you have to install that, but I'm not entirely sure. Because like when you install BAC0, it also installs async IO. So this means that it's an asynchronous library, which you really don't have to get into the weeds any on that. So before, with legacy BAC0 and legacy backpipes, they were synchronous code. That means that like all the code, everything happened one thing at a time, you know, down the line of your script. And if something was blocking here, it would just have to wait until that process completes, till it goes further down the line until it gets, from top to bottom, synchronous. And then async IO world, which I think is popular more in like networking stacks and complicated processes where we request data, and then we can while we're waiting, we can ask for another thing going on. So you can wait, and everything happens asynchronous. So like there's many different things that can happen once, all asynchronous, handled by the syncIO library. So yeah, it can get really complicated where things can go, hundreds of things asynchronously can all be happening at the same time. But it's kind of cool. And we don't have to get into what that means. So I think we can do BACnet equals BAC0 dot light. And then we can just do address in a string. So we talked about this before. So strings, and then we do object type. So I think this is where our analog input 1. Then, oh no, I guess we can just do analog input. And then we can do, this would be like our point address equals 1. I wonder if you need that in a quote. You might need that as a string. So, and then I think we can just do our request in BACnet. So yesterday we talked about F strings, how you can inject more data into the into the string with curly braces. So I think the format that we want, I think we can do like this. So we want the address, object type, and the point address, and then we're only considered with I think it's just present value. So hopefully this makes sense. So we have like an F string here, getting kind of fancy already, sneaking in our address and our analog input for our sensor reading. And then we should be able to just read BACnet. So I think we do. So we have to define like, so we're going to request a sensor reading. So we could just say sensor equals, I think we can just say await BACnet.read request. Of course I spelled BACnet wrong. And then I think we just have to basically run it. So like in these kind of programs in Python, you do like if main equals, no, if name equals main. This makes it's really weird way of how you run programs in Python. You do a syncIO dot run. And for some reason it's not happy. Oh, I think I know. So we have to wrap this into another function called await def. So we're defining a function. We're getting a little complicated here. In the synchronous function, I think we can just do this. Still not happy. pass in our function. So this is getting a little more complicated than I thought. I wonder if there's an easier example we could look at. Looking at some more examples here. Alright, so why is this not happy? I'm going to just put this in here. Await allowed only within async functions. So, oh, whoops. There we go. So right now this is just some asynchronous code right here. Actually, I don't think we need this inside the function. And we should be able to just print this. Print sensor value. See where this goes. Ooh, okay, so we have our loop. I think maybe we do need this inside of our, let's try that. Oh, there we go. Oh my gosh, we printed a sensor. 361. And then we can check it with our, if this was a real, this is what I do. If I was playing around on a construction site or a real building with a live sensor, I would be playing around with making scripts. And then with your BACnet scan tool is validating that you're doing the same thing with a different tool. And one that I have a lot of faith in is this. I've used this a lot even before I started playing around with Python. So here's our same IP address as here, and then if I drill into here, analog input, oh, I got analog input 2. So that's why I was reading so high. So this is the value of 361. Yeah, that's why it was so high, because it's analog input 2. Okay, so hopefully this makes sense. And remember that, like the other tutorials, we were playing around with the round function. You know, you could do something fancy here too. So, and we rounded it, or else we could even do an F string right here where we could just, with some more curly brackets, just inject this value right into the F string like that. There we go. And then I think the really, really fancy way, instead of rounding, what software engineers would do is, I think you could define your floating precision for the sensor reading. There we go. So I think that's plenty for this one, guys, for this video. Hopefully this makes sense. So this is kind of like what we'll be playing around with this in this course, and it's kind of just important to understand that we defining variables, a lot of strings. So like a string defines the IP address, the object type, which is analog input, and then the point address is 2. And then to form that BACnet request, we had to define the BAC0 library and the light version of it, which I think is just bare bones, nothing fancy or data logging or plotting or anything like that. And then we put our request together, which will be a string ultimately. So that's our address, our object type, our point address, and then we pass in present value. And then we pass that off to BAC0. You know, another thing we could even do too is, I think like BACnet has many different properties you can read besides present value. Description. I have to like, but description is another one. And if you're anything like me, I have to just Google things to make sure that I spelled it right. Looks like I spelled it right. So we could just say description. Let's see what this says. Curious if this works. All right, I thought that would error out because like I think the description in BACnet, it would be like a string, and like this will return like most likely like what am I trying to say? It will return like a numeric value. We should get into BACnet data types too. But then this should be a string, so I need to remove my floating precision rounding. Ooh, and there we go. So the description of that point is called measured VAV airflow. Pretty cool, guys. So we could even put this down here and uh-oh. All this stuff is fun. So we could even say in here I'm just gonna copy this and then put it in here. We can even get rid of this line. Sensor, we can just say for the sensor reading is, so this is going to make 2 BACnet requests. So under the hood, BAC0 is asynchronously requesting to our test bench 2 BACnet requests, one for the present value and then another for the description of the point, and then we can put that all inside of a single string and print it to the console. There we go. So we have sensor reading is 444. All right, so now we're gonna get really fancy. Let's try this. Maybe this is getting a little bit more fancy than I anticipated for this third video. So we might even be able to do units, I think. I think this should work. I'm not entirely sure. Let's try it. Units. So right now we're passing units into here and then our final response back. Let's see if this works. Make this proper English. The sensor reading is units. Whoa, oh my gosh. So here we go. The sensor reading is 391 cubic feet per minute for the measured VAV airflow. And that is pretty cool. Okay, so like when the person that is a controls technician in the field, like they would have to define that in the device that it has units and it has a description. If the person that didn't define those, that might not print anything. So it depends on if the person that set up the BACnet device, if they defined units and the description. So pretty cool. Another thing we're saying is like when we're running this on our laptop in Windows and I have this BACnet Explorer tool open at the same time, where'd you go? So I just want to point this out. It's like you guys can see this. It's So this tool is open at the same time, and then I'm running this at the same time. See, like this is going to error out now because the operating system will not allow two BACnet applications running on the same computer. Doesn't matter if it's Linux, Mac, or Windows. Like, what you have to make sure if you're getting errors like this is like that you close out of your other application and then run your script again, and then it'll work. There is ways that I think you can, but that's really advanced topics, and I've never do that myself anyways. I don't think there would ever be a reason to do that, to run multiple BACnet instances on one operating system. But I've heard of more crazier things. So that's like the big takeaway is like make sure that you only run one tool at a time for BACnet. So I think that's plenty for today, guys. So we'll be trying to build off little scripts like this in the future, and try practice typing this yourself. I think BAC0 is like a really fun, easy library to play around with, and I've even built little apps for demand response, just simple code like this, and we'll get into making read and write requests as well. So maybe as we get into the course a little bit deeper, we'll be playing around with this stuff plenty. So I think like at the moment I'll save this as a simple read request, and then I'll push this to GitHub just so this is like something we know that works, and then this will be something I'll just modify for every course, for every day that we complete a new lesson. So thanks guys, hope you're having a great day.